Welcome to this explainer. Today, we're diving straight into an absolute architectural marvel hiding right beneath the surface of our digital society. We're going to unpack exactly how you translate human intent, which, let's face it, is incredibly messy and fluid, into flawless, executable machine code. And we're not just talking about building standard apps here. We're talking about the literal engineering of digital law.
Think about it for a second. We're dealing with two completely opposing realities. On one side, you've got human society and our rules. They're highly associative, unpredictable, and full of nuance. But on the other side, you have the rigid, unyielding physical execution of silicon hardware. So how on earth do you map a complex legal contract onto a microchip that only understands absolute binary, zeros and ones? Well, here is our roadmap for crossing what we call the Semiotic Bridge. 1. The Great Digital Divide. 2. Building the Legal DOM. 3. The FBR Translation Ladder. 4. The BI-DOM Synchronization. And finally, 5. Our Computable Legal Future.
Let's kick things off with Section 1, the Great Digital Divide. We really have to start by establishing the core conflict here, which is the massive contrast between human imagination and processor mechanics. We've got our human cognition, what researchers sometimes like to call OS alpha. It's warm, it's messy, it's beautifully fluid. But for a computer to actually do anything with that imagination, it has to cross over to the arithmetic logic unit, or the ALU. That's the physical silicon hardware. And the ALU is cold. It's rigid. It relies entirely on absolute deterministic logic gates. There is zero room for guesswork. So how do you bridge that gap? You use the Semiotic Bridge. This bridge is built entirely out of strictly formatted text. We're talking formats like JSON, Python, or XML. This text acts as the literal, physical interface you need to safely compile all that associative human imagination into the strict laws of physics governing those tiny processors. Text isn't just for reading anymore, you know? It's the deterministic operational literature that actually commands the machine.
Which brings us to Section 2, Building the Legal DOM.
So how do we apply this strict textual bridge to something as massive and complex as the legal system? Look, if you want a machine to understand a law, you can't just feed it a standard PDF. A PDF is just a flat, dead wall of text to a computer. Instead, we have to build the Legal Document Object Model, or legal DOM. Think of it as a digital skeleton. It's the hidden plumbing that maps chapters, clauses, and subsections into a living, hierarchical family tree of XML data. Now, a smart contract can actually read, understand, and safely execute that law without hallucinating.
To actually construct this digital architecture, developers rely on global XML standards like Acom and TOSO, which beautifully translates to linked hearts. And why go through all this incredibly tedious work to structure the data? It's absolutely crucial for preventing what scholars call moral crumple zones. That's a scenario where a system gets so complex that the machine basically obscures responsibility, leaving everyday humans to absorb all the damage of a probabilistic machine error. By using these deterministic standards, we guarantee that the machine executes flawlessly, but the law stays adaptable and firmly in human hands.
Moving right along to Section 3, the FRBR Translation Ladder. So, how does a fuzzy legal concept become concrete digital reality? The legal DOM uses something called the FRBR hierarchy to break this down into 3 totally distinct steps. Step 1 is the work. This is the purely abstract, raw idea of the law, like simply the concept of setting a speed limit. Step 2 is the expression. That's the specific English drafting of that rule. And finally, step 3 is the manifestation, the actual concrete XML file sitting securely on a physical server. Walking down this specific ladder guarantees atomic precision, tracking human intent straight down to the metal. Let's dive into Section 4, the BI-DOM synchronization. This brings us to a multi-million-dollar structural problem. If the underlying XML is so incredibly strict and unforgiving, how on earth can a human lawmaker actually draft or edit a law without breaking the entire mathematical system? I mean, you can't exactly ask a politician to write perfect, schema-validated XML code just to tweak a comma in a bill, right? The whole system would grind to a halt. The fix for this is an absolute architectural masterpiece known as the BI-DOM synchronization pattern. It solves the problem by running 2 completely separate document layers at the exact same time. On the human side, you've got the editor DOM. It's a lightweight, super intuitive visual interface where a person just types normally. But hiding right behind it, totally invisible to the user, is the stored DOM, the structurally strict, schema-validated XML that holds the absolute mathematical truth of the law. Here's how that synchronization isolates human freedom from machine logic. Step 1. A human types naturally into that user-friendly editor DOM. Step 2. An invisible edit capture extension silently grabs those precise keystrokes and encodes them as coordinate formats, completely ignoring the visual layout. Step 3. Those coordinate changes securely rewrite the strict XML stored DOM in the background. The human gets to act human, the machine gets its unbroken math, and it all synchronizes perfectly without the user ever seeing a single line of complex code.
Finally, Section 5, our computable legal future.
So why does engineering this level of precision matter so much? Well, I absolutely love the poetic reality of this quote from the source material. We are quite literally tricking rocks into thinking using lightning and text. There is no magic ghost in the machine. A computer doesn't comprehend a legal contract, it just processes data. The machine is literally just a deterministic bridge executing our structured text. The actual spark of intent, that always belongs to the human.
And because the machine has no inner self, this entire framework relies on what researchers call human proversion. That is, the genuine sweat-of-the-brow effort. It's the proactive, painstaking manual steering required by a human pilot to enforce their exact intent. You have to assert total control over that structured text to override the algorithmic distortion and probabilistic guessing that inevitably happens when you let automated AI take the wheel. We have to be the sovereign gate. Which leaves us with a pretty profound choice as we build these executable digital societies. In a world increasingly run by massive, lossy statistical engines, will you actively use structured text to build deterministic fidelity, or are we going to let probabilistic noise and automated guessing take control of our most foundational societal rules? The friction you feel crossing that semiotic bridge, that is the ultimate proof of your agency. I'll leave you with that thought to chew on regarding your role as a steward of the machine. Thank you so much for joining me on this explainer. Keep learning and keep building carefully.